Imagine teaching a dog to fetch a ball, not by telling it how, but by giving it treats when it does the right thing. Now imagine if computers could learn like that too. Welcome to reinforcement learning, the science of decision-making through trial and error. Reinforcement learning, or RL for short, is a type of machine learning where an agent learns to make decisions by interacting with an environment. It learns not by being told what to do, but by receiving rewards or penalties for the actions it takes. It's inspired by how humans and animals learn. We try things, we fail, we succeed, and we remember what worked. Before we dive deeper, let's understand a few key terms in reinforcement learning. Agent. This is the learner or decision maker. Think of it as a robot or AI system trying to learn the best way to act. Environment, the world the agent interacts with. It could be a game, a robotic arm, or even the stock market. State, a snapshot of the environment at a particular moment. Action, what the agent decides to do in a given state. Reward, a feedback signal. Positive reward for good actions, negative for bad ones. Policy, the strategy the agent uses to decide what action to take in each state. Episode, a complete sequence from start to finish. For example, one game of chess or one robotic task. So, how does an agent actually learn? It follows a loop. First, it observes the current state of the environment, then it picks an action based on its current policy. The environment responds with a new state and a reward. The agent uses this experience to adjust its strategy, trying to maximize the total reward over time. One of the most interesting challenges in RL is the balance between exploration and exploitation. Exploration is trying new actions to discover their outcomes. Exploitation is using what it already knows to get the best reward. A good agent must balance both, like trying a new restaurant versus going back to your favorite. One of the most interesting challenges in RL is the balance between exploration and exploitation. Exploration is trying new actions to discover their outcomes. Exploitation is using what it already knows to get the best reward. A good agent must balance both, like trying a new restaurant versus going back to your favorite. There are different flavors of reinforcement learning based on how the agent learns. Model-free RL. The agent learns by trial and error without understanding how the environment works. Q-learning and deep Q networks are examples. Model-based RL. Here the agent builds a model of the environment and uses it to plan ahead, like playing chess in your head before making a move. Some popular algorithms in RL include Q-learning, a value-based method where the agent learns a Q value for each action in a state. Deep Q networks, or DQN, combines Q-learning with deep neural networks for handling complex, high-dimensional environments. Policy gradient methods. Instead of learning values, these learn the policy directly. Actor-critic models. They use two models, one to make decisions, actor, and one to evaluate them, critic. Reinforcement learning is behind some of the most exciting breakthroughs in AI. It helped DeepMind's AlphaGo defeat a world champion at the game of Go. In robotics, RL teaches machines to walk, pick up objects, or fly drones. In recommendation systems, it helps suggest what to watch next. It's even being explored for traffic control, finance, and healthcare. Despite its power, RL has some big challenges. It can be very sample inefficient. It needs a lot of interactions to learn. Sparse rewards make learning slow. What if you only get a reward at the end of a long task? Exploration can be risky, especially in the real world, like with self-driving cars. Reinforcement learning is like teaching a computer to learn from its own experiences, just like we do. It's powerful, it's complex, and it's shaping the future of AI. Whether it's mastering video games or solving real-world problems, reinforcement learning is giving machines the ability to learn from life itself. Thank you everyone for watching this video. If you found this video helpful, hit like, subscribe, and drop a comment if you want a deep dive into specific RL algorithms. Until next time, keep learning and keep exploring.